Welcome! In this video, we are going to take a look at problem 2 from Chapter 23 of College Physics 2E by OpenStax. In this problem, we need to find the magnitude of the magnetic flux through the coil due to the wire in part B of the figure. We are told that the wire is perpendicular to the coil, and we note that the wire will make a field that is into the page at the location of the coil. We also note that the normal to the area of the plane of the coil is up the page. This makes the angle between the magnetic field and the normal 90 degrees. Again, that is since B is into the page and N hat is up the page. The result is a zero magnetic flux through the coil. We can see this mathematically since the flux is equal to B times A times the cosine of the angle between B and the normal to the area. We call it theta. Okay, so we have flux is B times A times the cosine of 90, and the cosine of 90 is 0. So we have flux is B times A times 0. That results in a flux of 0 Tesla meters squared. I hope you found this helpful. Let me know in the comment section if you have any questions. Thank you for watching, and I'll see you in the next one.